Now we're going to solve this integral. Well, it's the same as surface integrals. So, um, we're calculating a value over 3D because we have x, y, and z. Um, so to solve this, we need to convert the surface integral into a double integral using the parameters of u and v. So we have our vector, which is, well, it's this one. What? Ah, sorry. It's this one. And the function for this is f of x, y, and z equals, no, sorry, equals y, which is this one. And the limits, which are these ones. Okay. Sorry. Um, Now, since our function is y and form, we know that y is u sine of v. So first we're gonna have our u, which is the u, the r, which is cosine of v, comma sine of v, comma 0. Okay. And our v, which is the v over the r, which is minus u sine of v, comma u cosine of v, comma 1. Okay. Now we're gonna do our favorite thing in the world, a cross product. Okay. So it's ru rv plus I j k f cosine v sine v 0 minus u sine v u cosine v and 1. And for this, we have in I, it's sine v times 1 minus 0 times u cosine v, uh, which is sine of v. For j, it's minus cosine of v times 1 minus 0 minus u sine v, which is minus cosine v, and in k it's cosine v times u cosine v minus sine v times minus u sine v, which is u cosine square of v. Sine square of v, which is u. Now we're gonna have our magnitude, or u of v equals sine v square plus minus cosine v square plus u square, which is 1 plus u square. Ah, okay. Now we're gonna set up the double integral that I mentioned at the beginning. Evaluation p0 0 to 1 u sine of v 1 plus u square du dv. Now first we're gonna integrate this. So it's gonna be row of 0 to 1 u sine of v 1 plus u square du. Okay, so we're gonna use substitution. So we have w equals 1 plus u square and dw equals to u, which is half dw, which is u du. Okay. Now the limits, we have u equals 0 So W equals 1. And if U was 1, then W is 2. Okay? So for this integration, we're gonna take out the sign. So it's gonna be sine of V, integral from 1 to 2, half W to half dW. Now we're gonna evaluate it. We're gonna take out also a half. So it's gonna be sine V over 2. And what we're gonna integrate, it's gonna be 2W3 over 2 over 3 from 1 to 2. And this is sine V over 2 times, oh well, no, yes, times 2, 2 to the 3 and half over 3 minus 2, 1 by 2 half over 3, which is sine V over 2 times, oh well, look at this, we can cancel this, this and this. This is 1. And it's gonna be sine V over 3 minus sine V over 3 by, and it's 2, 2 minus 1 over 3. And now we are going to integrate that one with p and 0 from 0 to p. So it's integral from 0 2p 2 square root 2 over 3. No, wait, I don't know why I did this. Yes, sorry. So the sign, it's just a simple, it's a constant in both. So we can also write it as it was, as sine of v times 2 square root of 2 minus 1 over 3. Okay, and that is what we're going to evaluate from 0 to p. We're just gonna duplicate this one. Duplicate. I'm gonna put it right here with respect to v. And this one is a constant, so we're gonna take it out. 2 square root of 2 minus 1 over 3 from 0 to p as sine of v dv. Okay. 2 square root of 2 minus 1 over 3 from 0 to p. And the integral for this one is minus cosine of v from 0 to p. So it's gonna be 2 square root of 2 minus 1 over 3 times minus cosine of p. And we don't have to uh put the 0 there because it's basically no, never mind, we have to, because this is one is different, minus cosine of 0. And the result it's minus 2 plus 4 square root of 2 over 3, which is the same as 1.22. But both are correct. They're the same. And we're done. This is the result of the integral. Sorry. And we got it. Thank you.